We're on page 50 and we're going to do the following problems. Number 6 right here, number 12, number 22, number 27, number 28, and number 30. So we're going to do a total of 6 problems, 6, 12, 22, 27, 28, and 30. So let's move ahead to number 6. And remember that in all these problems we have to simplify expressing the answers with positive exponents only. So number 6 is a relatively simple problem. We've got to multiply 2x cubed by 7x squared. So the first thing we do is just take the numbers first. We always do the numbers first. We're going to multiply 2 times 7. That's right over here. And then we're going to apply the product rule. So we're going to add the powers 3 plus 2. I get 3 plus 2 over here, which gives me x to the 5th. So the answer is 14x to the 5th. Normally, the number goes right at the beginning, and then goes the variable, and we should always have positive exponents with the variable. Let's move to the second problem, where we have multiplying minus 2x squared by 4x cubed, which is bracketed and then has the power minus 1. So first thing we're going to do is apply the power rule, multiply m times n to get mn on the second bracketed, this part here. So you're going to multiply the 3 times the minus 1 for both the 4 and the x cubed. Remember, this is 4 to the 1 here. There's an implied 1 here. We're going to leave this the same in the first part of the problem. So we have minus 2x squared. Now we're going to multiply 1, because this is 4 to the power 1, by minus 1. And we get minus 1. And then we're going to multiply 3 times minus 1 and get minus 3. So we've applied the power rule here. Now we have minus 2 and 4 to the minus 1. So we're going to move this from the numerator to the denominator in order to make the 4 with a positive exponent. Here we have a negative exponent, so 4 to the minus 1 on the numerator becomes 4 to the plus 1, and we don't put the 1 there. So we've moved that down, and now we're going to add by the product rule, x squared and x to the minus 3, we get 2 minus 3, which is this rule here. We add the exponents by the product rule. Okay, and so 2 minus 3 gives us minus 1, and minus 2 over 4 reduces to minus 1 over 2. So we're reducing this part, and the x to the minus 1 goes from the numerator to the denominator and becomes x to the plus 1, and we don't put the power 1 in there. So we're using a mixture of power rule, product rule, and also the rule that states that x to the minus power is 1 over x to the plus power. In this case, it's minus 1 becomes plus 1. So the next problem looks very complicated, but actually we know that anything to the 0 power is 1. So we've got this bracket here and here, and we're raising it to the 0 power. It doesn't matter what's in here. Anything to the 0 power is 1. So we're going to place that with 1, and essentially all we're going to do here is work on the denominator and apply the power rule to the denominator. So the minus here is the minus here, and then we're going to multiply 4 times minus 2, going to get minus 8. We're going to multiply minus 2 times minus 2, We're going to get plus 4. And you get plus 2 times minus 2, which gives us minus 4. So all we've used is the power rule to remove this minus 2 and multiply each of these by minus 2 to get this. Now, this has a negative exponent, and this has a negative exponent. So we're going to move these from the denominator to the numerator, make it plus 8. This is minus 4. Move it from the denominator to the numerator, make it plus 4. And the y4 stays where it is on the denominator. This minus, we're going to move here to the front here. So we get minus x to the 8th, z to the 4th over y to the 4th. Now this problem actually, one could just stop right at the very beginning and say the answer is 1, because anything to the 0 power is 1. And you can see this whole bracket here and this term here is all raised to the power 0. So you could just put 1, but let's look a little carefully at this. Look a little more carefully and see what sort of things we can sort of use to prove this. And so we've got, we're going to remove the power 3 here from this bracket here and multiply it by the 55. So we get 55 times 3. We're going to get b to the 23 to the power 3. And so we've multiplied the 3 times the 55, and we've multiplied the 3 times the 23. And we've still got the 0 power here. The denominator we're not going to change. And now 3 times 55 is 165. 3 times 23 is 69. And this stays the same. So all we're doing is multiplying this times this and that times that and coming out with these numbers. Now we're going to multiply the 0 times the 165, the 0 times the 69, and the 0 times the minus 16. So we do that here. And anything times 0 is 0. So we get a to the 0, 69 times 0, 0, b to the 0, and a to the 0. Now each one of these is 1. Or you could cancel the a to the 0s if you want. You still have b to the 0, which is 1. It doesn't really matter. Your answer comes out to be 1. So you can just write 1, but it's good to show that you understand what's going on. Now, in this case here, what I'm going to do is multiply consecutively first this coefficient, first by the 3 and then the 0. Multiply this coefficient by the 3 and then the 0. And multiply this one only by the 0. So what I've done here is first I've multiplied by the 3. So I've got this, which is exactly the same as this part here. But now I'm going to multiply, put in the power 0, and apply it to each term. And I still come out to a to the 0, b to the 0, 1 times 1 times 1. It's still 1. So really what I'm doing is multiplying the 55 by the 3 and the 0. I'm doing it in one step. And then I'm multiplying the 23 times the 3 times the 0. So I get that. The minus 16, I'm only going to multiply by the 0. But it doesn't matter because I get a to the 0, b to the 0, a to the 0. So whether you do it this way or you do it that way, or you realize that this has to be 1, it doesn't, either methods of the methods is good. So here in this problem, what we're doing is we're taking this problem and we're going to multiply, going to handle each one of these terms separately, this term and this one separately. But I'm going to multiply the minus 2 times the minus 4, and that's the power rule right here. So I get a to the 8th minus 2 times minus 4 gives me a to the 8th. b to the 3 times minus 4 gives me b to the minus 12. a to the minus 3 times minus 2 gives me a to the plus 6. b squared 2 times minus 2 gives me b to the minus 4. Here, there's a to the 1 and b to the 1, even though we don't write it in. So 1 times minus 4 gives me minus 4. And for the b, 1 times minus 4 also gives me minus 4. Now what I'm going to do is collect all the a terms. So I've got a to the 8th, which is this one. I bring a to the 6 from the denominator to the numerator, call it minus 6. And this minus 4, I'm going to bring up and bring it plus 4. So I've got the term a8th, a6, and a4. That's the 3 places where the a appears. a to the 8th, since it's on the numerator, I'm going to keep it the same. Since this is on the denominator and I'm bringing it up to the numerator, I'm going to change the sign to minus 6. And because this is minus 4 on the denominator, I'm going to bring it up to the numerator, becomes plus 4. Similarly, for the b term, I have minus 12. Bring the minus 4 up, it becomes plus 4. Bring the minus 4 up, it also becomes plus 4. Now, I collect, I've got 8 minus 6, which is 2. 2 plus 4 is 6. b minus 4 plus 4 is minus 8. Minus 8 plus 4 is minus 4. So this is just arithmetic to go from here to here. And now I want my exponents to be positive, so I'm going to move b to the minus 4 from the numerator to the denominator, and here we have b to the 4th. Now the other way that I could do this is applying property 4 to the first step, where I take the terms with negative exponents and I move them from the numerator to the denominator and the reverse too, so that b to the minus n becomes b to the plus n, because I'm moving this up, and this moves down and becomes plus. So in this case, what I'm going to do is take the a to the minus 2b cubed minus 4 and move it down, and the only change is here. The minus 4 becomes plus 4. In the bracket, it stays the same, exactly the same. Now I'm going to take this term, leave it as it is, and move it from the numerator to the denominator, and now it's plus 2. Notice what's in the bracket stays the same. The ab to the minus 4 moves from the denominator to the numerator and becomes plus 4. Now I multiply 2 times minus 3, get a to the minus 6. 2 times 2 becomes 4. A 4th, b 4th, because there's a power 1 and a power 1 associated with both the a and b. Now I multiply 4 times minus 2, I get a to the minus 8, and 3 times 4, and I get b to the 12th. Now I collect the terms, and I get a to the minus 6 plus 4 plus 8. Minus 6 plus 4 plus 8, because I'm moving this from the denominator to the numerator. So I've collected all the a terms. Similarly with the b terms, I've got 4 plus 4 minus 12. 4 plus 4 minus 12, because this moves up and changes sign. I still come out with a to the 6, b to the minus 4 as I did over here, so I get exactly the same answer. So when you're doing these problems, there's always more than one possibility to get the solution. Okay, and now number 30. again, here what we're going to do is we're going to use the power rule, but we'll use it on the numerator first, not touch the denominator, and then we'll use it on the denominator. So what we'll do here is, first of all, we have minus 2 to the minus 3. We're going to first of all multiply the minus 3 times the 2. This is 2 to the 1. So we get minus 2 to the minus 3. The x is to the 1. So I'm going to multiply 1 times minus 3. I get minus 3. And I'm going to multiply minus 3 times minus 3. So that handles the numerator. What I'm doing is applying the power rule to the numerator only. Okay, right here. So I get minus 2 to the minus 3 because there's a 1 here, and 1 times minus 3 gives me minus 3. The x has a 1, so that becomes minus 3, and the minus 3 times the minus 3 gives me plus 9. On the bottom, applying the power rule to the denominator now in going from here to here, minus 1 times 1 gives me x to the minus 1. Minus 1 times minus 1 gives me y to the 1. So I've used the power rule first in going from here to here, and then in going from here to here. Now what I'm going to do is collect the x terms. So I have minus 3. I'm bringing this up. It becomes plus 1. The y is 9. And when I bring the y up, it becomes minus 1. This 1 becomes minus 1. The minus 2 is to the minus 3. So I'm going to bring that and bring it down. Notice it's the bracket around the minus 2. Keep that the same. And the power minus 3 changes to plus 3. So when we multiply these out, this becomes x to the minus 2. I mean, when I add these two terms, I get x to the minus 2. And I'm going to bring it down and make it x squared right there. The y is to the 8th. Minus 2 multiplied by itself, minus 2 times minus 2 times minus 2 is minus 8. On the denominator, it's like this. And that's where we get the minus sign that appears here, because minus 2 cubed is minus 8. I can move the minus to in front, or I can put it on the numerator. Either of these are equivalent, and I get minus y over 8x squared. Notice that all the powers are positive. So that completes our discussion on these problems.